Welcome to the Computer Aided Engineering Graphics. This is Upender working as an assistant professor in the Department of Civil Engineering in Andhra Engineering College. Today I would like to explain about development of surfaces from this course. What is meant by the development of surfaces? For example, it is a three-dimensional object like square, three-dimensional object, square. It is unfolded. It is a plane surface. If the three-dimensional object it is unfolds like plane surface. It is helpful for the manufacturing of the metal sheets in industries. It is nothing but development of the surface is the shape of a plane sheet that by proper folding could be converted into the desired object. In engineering practice, a large number of objects like milk cans, funnel, bucket, measuring flask, duct of air container, hopper, chimney, tray, storage tank, boiler shell, etc. These all are the three-dimensional objects shown in figure are made up of the metal sheets. These all are the three-dimensional objects. If these three-dimensional objects proper unfolding forms the metal sheet. The fabrications of these objects can be planned in an economic way if the accurate shape and size of the metal sheet is known. The chapter deals with the proper layout planning of the surface of the object on a single plane called the development of surfaces. These are the objects like metal sheet, hopper, it means funnel, and milk bucket. Here, next one measuring flask, and next one duct of air container, hopper, chimney, tray. These all are the three-dimensional objects. If this three-dimensional objects unfolds, it forms a plane surface. Means it is three-dimensional object into two-dimensional object. Let us know more about the development of surfaces. The development of surface in engineering drawing refers to the process of unfolding or laying out the entire surface of the three-dimensional object into a two-dimensional plane, showing the true shape and size of each face or surface. This technique is essential in sheet metal work, fabrications and manufacturing, where the plot pattern is used to cut and assemble of the objects of the three dimensions. And next one, methods of the surface development. In this development of the surface are the following four methods used to develop the surfaces. They are parallel line method, radial line method, triangulation method, approximate method. Let us know more about each and every method. Parallel line method, it is used for prism and cylinders where the surface are generated by a parallel lines. The lateral surfaces are represented as the rectangles and the true lengths of edges are maintained in the parallel line method. And then second one is radial line method. It applied to the pyramids and cones where all edges or generators converge to a single point. It means fx points. The lateral surfaces are developed as a sectors of a circle. Then third one is the triangulation method, used for complex or irregular surfaces where the surface is divided into triangles and each triangle is developed individually. And last one is the approximate method, used for surfaces that cannot be developed exactly such as spheres by approximately the surface with developable shapes. In this development of surface methods, first one is the development of prisms, second one development of pyramids, third one development of cylinders, and fourth one is the cone. Let us know more about the development of the prisms. Development of prisms explained with the help of one example problem. That one is a square prism of the base at 30 mm and axis 60 mm is resting on its base on the horizontal plane with a rectangular face parallel to the vertical plane. Draw the development of the prism. So we are first of all to draw the one reference line. It is X line, sorry, Y line, vertical line. It is an horizontal line. The problem is a square prism. First of all, draw the square prism shape here. It is the square prism. If the observer is here, if the observer is in front of the square prism, the observer is here, the object of the square prism is in front of you, looks like a rectangular. The observer is here to show the square prism from in front of the square prism. The observer only see the rectangular face in front view. Front view rectangular face. And in top view, if the observer looks the object in the top view, it means only the visible portion is the square shape. So rectangular face in the front view, it means the front view rectangular face is drawn above the reference plane, and below the reference plane is square. Let us see more about this diagram. First of all, to draw the reference line, this is the reference line of XY plane. First of all, to draw the true shape. True shape means top view. Top view is the square and a rectangular face in front view. Front view means above the reference plane, and the condition is here axis 60 mm is resting on its base on the horizontal plane and with a rectangular face parallel to the vertical plane. Rectangular face is parallel to the rectangular face is parallel to the vertical plane. Clear? To draw the triangular face on the rectangle face on the horizontal plane with the axis of 70 mm. It means the height is 70 mm and each side of the square is the 30 mm. Each side of the square is the 30 mm. If the square is, each side of the square is 30 mm, it means the each side of the here the each one side is the each one side is the 30 mm. If the unfold this square 4 into 30, 4 into 4 sides, square is having 4 sides, into each side is 30 mm. 4 into 30, 120 mm. 120 mm is length and width is the, width means axis is the 60 mm. To draw the rectangle of 60 mm height, 60 mm height, and the width is 120 mm, means 12 centimeters. 12 centimeters. So to divide this 120 centimeters into every 30 meters, every 30 meters. One, two, three, four. 4 equal parts. The entire rectangular plane surface divided into 4 equal parts, means the square is having 4 sides. Each one is the 30, 30, 30, 30. 120 mm. So the width is the 60 mm and length is the 120 mm. It denotes here small a, wait, small a, here small a, here B, C, D. So let us start from here, capital A, B, C, D, and again A. Again A, it means, for example, it is A. Let us see. It is shape A, B, C, D. So A again touches to the last phase, fourth one. So that's why it ends with A. Again A, capital A. A, B, C, D, and A. It means this edge is touches to the here. It is the unfolded square. Height is 60 mm and the length is 120 mm. To calculate the area of this rectangle is also possible. Plane shape. Then coming to second one. Draw the development of complete surface of the cylindrical drum with lid diameter is 30 mm and the height is 1.6 times the diameter. 1.6 times the diameter. If the diameter is of the cylinder is 30 mm, to draw the circle with 30 mm and it projects into the, it means cylindrical prism. The shape is the cylindrical prism. It means top view is the cylinder and front view is the rectangle. First of all, to draw the circle, it divides into 8 equal parts, then project the each edge and each end or generators into the top view, generators into the front view to draw the rectangle into the front view. Then to calculate the height of the rectangle and the length. Height is the 1.6 times of the diameter. 1.6 into 30 mm. The height, it means height of the cylinder is 1.6 into 30 mm. 1.6 into 30 mm. It means 48 mm is the height. Sorry, 48 centimeters. Given dimensions is centimeters. The height is in centimeters. 48 centimeters, and the overall length of this rectangle shape, it means plane shape. Plane length is 5 means 3.14 into 30. 5D is the length of the circle. It means lateral surface of the circle is the 94.2. 94.2 is the length. 94.2 is divided into 8 equal parts. Each one is the 8 equal parts, 11.775. Each one width is 11.775 is the width of the each one. It is the development of the cylindrical drum. Then next one is the radial line method. It is a radial line method. A pentagonal prism of the base at 30 mm and axis is 70 mm is resting on its base on the horizontal plane with a rectangular face parallel to the VP. It cut by the axillary inclined plane whose vertical traces is inclined 45 degrees to the reference line and passes through the midpoint of the axis. Draw the development of the lateral surface of the truncated prism. Means the pentagonal prism of the each base side is 30 mm is given, and axis height is the 70 mm is the axis height. Is resting on the horizontal plane. The rectangular face is resting on the horizontal plane. It is the 30 mm, 70 mm height, axis height. And rectangular face is parallel to the VP. It is parallel to the vertical plane and is cut by the axillary inclined plane with the 45 degrees to this rectangular shape. For example, I am taking here 45 degrees to draw the line here to mention the each and every generator. Every generator is cut by the axillary inclined plane to mark as each and every one. For example, let us start with the P at the A and B point. The point is Q, and C point, the point is R, and D point S, E is the T, and project this each and every points along these points, and to connect all these points to form a truncated prism. Thank you.